Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This episode is brought to you by Ultra Air, whole house ventilating dehumidifiers. Here at Positive Energy, we've been working with these dehumidifiers for years on many of our integrated mechanical designs, and we've seen such great results for both the health and comfort of our clients. We even have an Ultra Air dehumidifier in our office, and we absolutely love it. When you're working with an airtight and well-insulated building, you quickly notice the outdoor air infiltration restrictions that occur, which allows pollutants and moisture levels to accumulate inside. So when you think about it, properly controlling that moisture in your home will definitely improve the effectiveness of your air sealing and insulation efforts, and will definitely improve the health and comfort for your client, your family, you. Just imagine being able to run your air conditioner at a higher temperature without feeling uncomfortable, and knowing that this improved comfort is coupled with fresh filtered air. These are just a few of the many benefits of incorporating the Ultra Air dehumidifiers into your home or your project. It really is an easy choice to make. To learn more about the best strategy for controlling moisture in your home, check out ultra-air.com, that's air with an E at the end, and see how a whole house ventilating dehumidifier can work for your home or project.
Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello everyone and welcome back. Welcome back to the Building Science Podcast. I'm Christoph Irwin, your host, here with my producer, Miguel.
Hello.
And today we are doing part 2 of our thermal comfort episode in our IEQ series. So if this happens to be the first episode of the Building Science Podcast that you've tuned into, thank you for being here, but actually you should stop now and go back at least one episode, and listen to the first part of this one, our interview with Robert Bean. You might want to go back 2 episodes and listen to the Intro to IEQ series, but I'll leave that part up to you. So, reminder, we are talking to Robert Bean today. He's an engineer and an educator and an articulate man. Again, for the full introduction to who Robert is, go back 1 episode. Where we were last time, we were just getting through a rather wide-ranging discussion framing the issue of thermal comfort and its importance for the built world. And we were getting into the crunchy side of things. We were getting into the 10 factors of thermal comfort. So without further ado, here we go. Okay, so let's go through those 10 factors. So there's 10 factors in 3 categories, right?
Correct.
Okay.
So the general factors, and this is, oftentimes you hear people talk about ASHRAE 55 and they say there's only 6 factors. Well, they're missing 4 of the key factors. And in fact,
that'd be me sometimes.
Yeah, well, yeah.
Go ahead.
Eventually, you'll catch on, Christoph. You're a smart guy. You got lots of letters behind your name, And anyway, you actually worked at NASA, didn't you? Didn't you do a stint in the space program?
Yeah, I worked at a wind tunnel lab supporting NASA projects, but that was in the 80s. Yeah.
Yeah. So 10 is only 4 numbers more than 6, right? So you'll get it eventually.
I'll get to the 4. I'm curious to know which 4 I've been missing. So there's the 2 personal factors. Let's get the 2 personal factors out of the way, right?
Okay, the 2 personal factors.
What you're doing and what you're wearing. Yeah, go through them, please.
Yeah, exactly. So, you wear a lot of clothes, you have a high clo value, more insulation, right? You have less clothes, you got less insulation, so you have a low clo value.
And clo is the letters CLO. I just want to point that out, CLO, and we pronounce it clo, and it's standing for a unit of clothing.
Right, it's an insulation value. Okay, and I don't remember what, it's the inverse of conductivity. So, what is that? In SI,
thermal transmissivity.
Yeah, you guys are in IP units. So, anyways, okay, so it's an insulation value. I should know that off the top of my head in IP units, but I don't. Okay, then metabolic rate just is a representation of how much heat you're producing. So, we're sitting here chatting, and our MET rate is, probably somewhere in the 0.9 to 1.1, right? But if we got up and we went for, let's just say we did some yoga. You and I both do yoga. We're man enough to admit that we do yoga. But you do extreme yoga, like you're like hardcore.
Manly yoga.
So like you're starting to push met rates, in your yoga practice, that are like 4, 5, 6 type of stuff. My met rate in yoga is like, 2, 2.5. But so, if you do a lot of work and you have a lot of clothes on, you're going to overheat, right? So you don't do that. When you know you're going to do a lot of work, you dress down. So that's the 2 personal factors. And then we have the 4 general factors. And that's what we call the dry bulb temperature or the air temperature. That's typically what the thermostat measures, is the dry bulb, right? So for the audience today, what we joke about this is that, you take a $20 thermostat and you throw it up on the wall and you connect it to, the most affordable low-end device, and you call that a comfort system, when in fact there's like 10 other things that you need to think about, and you compare it to the
building.
So it's just, so anyways, the dry bulb temperature, air temperature, let's just call that the same. And then we have this term, I love this topic, mean radiant temperature. People shouldn't get afraid of that term. You need to embrace it, right? MRT, and we can come back to that. And then humidity, and then airspeed. So those are the 4 general factors. All right. So so that in our topic here, let's just put a sidebar for mean radiant. If we have time, we should come back and talk about that, because that really discusses the relationship between the human body and the enclosure as MRT. All right, and then we have the 4 local factors, and these are the ones that people typically forget. And the local factors are vertical air temperature difference, so that's the temperature between your ankles and your head.
Stratification,
okay? Stratification, gratification, okay? So we have to make sure that that's not too excessive, okay? And then we have this other great term called radiant temperature asymmetry. Okay, so symmetrical means the same. Asymmetrical means different, right? So radiant, so different radiant temperatures on either side of you. And everybody's experienced that, and we can talk about that one. And then the other one is floor temperatures, which is really important. And so you don't want the floors too cold or too hot, otherwise people will complain about it. And that's where, radiant floor heating and cooling comes into play. And then the other one is drafts. And I'm not talking about beer, right? Although draft is good. We're talking about, that stream of air that comes across, down from windows across the floor, or from cold walls, or cold ceilings. You get these drafts. So those are the sort of the 10 key metrics inside the standard. And but if you really wanted to dig down, there's a few more, but those are the 10 ones, the 10 major ones.
Let's do that sidebar. Let's leave radiant temperature asymmetry for another day, but let's talk a tiny bit more about MRT and how the body relates to MRT. Embrace the MRT.
Embrace the MRT. So the holy grail of HVAC that's control comfort with a thermostat, an air temperature device. So this is going to come as a shock to everybody that's listening today. But the heat transfer that you have between the body and the space is predominantly a radiant transfer. It's not air-based. And the ASHRAE handbooks and the medical journals and the journals on indoor environmental ergonomics are very clear on that roughly 60% of the transfer from the human body to the environment at normal activity levels is actually radiant. It's not air temperature. So why is that important? Well, when we look at the relationship between the skin temperature of the body and the skin temperature of the enclosure, if those temperatures are identical, there's nothing motivating energy to move from one surface to another. Any movement of consequence, let's call it that way. But when we have a really bad building in a cold climate or a bad building in a hot climate, the inside temperature of the wall, the skin of the wall, is going to go up or down. relative to the skin temperature of our body, which varies depending on whether you're measuring your foot or your head or your hands. So the more difference between the skin of the enclosure and the skin of the body, the more energy exchange you're going to have via radiation. And so this MRT describes what each of us feels from a radiant perspective in the space. Now, they call it the mean radiant temperature because everybody that's listening online right now, let's just pretend that you're in your room and in front of you is a wall and it has a certain temperature, and to the right of you and to the left and behind you are this wall enclosures. Then you have the ceiling and the floor. And these temperatures vary. So you could have maybe to the right of you a wall that's all glass, south facing, high intensity energy on that glass, and so that glass temperature is going to get really hot. It can get as high as 95 degrees on the inside temperature. And to the left of you could be a wall that could be at 65 or 70 degrees Fahrenheit. And so you take a look at all of these surface temperatures and it has an impact on your experience, a radiant experience, and it's an intimate experience with the enclosure. And that's what MRT is all about.
Yep, good. And, I love what you said in the beginning, the idea that people in the building, they don't actually experience the room temperature. They experience heat loss or heat gain from the body. And that's just such a big paradigm shift for a lot of people to take in. So we can beat that drum again and again. We don't experience the air temperature in the room. We experience heat loss and heat gain to the body. But it is true that we're kind of rinsing the walls, ceiling, and floor with the air to try to control that surface temperature, right? So air does influence the mean radiant temperature.
Yes, of course. Well, air. We're not saying air is not important, but we're saying that we control our spaces with a device that measures air temperature. But that's not the major or the predominant mechanisms. It's radiant. So there's this other term that we have in the field of thermal comfort, and it's called operative temperature. And operative temperature is the marriage between the mean radiant and the air temperature. So when we bring these two together in harmony or in matrimony, we represent that marriage with this term called operative temperature. And operative temperature is actually what the human body is experiencing.
And are there thermostats available that measure operative temperature?
Yes, there are. And in fact, a couple of manufacturers that do make them. They're not mainstream in residential yet.
Why not? That's maybe a philosophical discussion.
Well, part of it is that when you look at profit is one of them. Part of it is, but people in the world of manufacturing, which is dominated by the air industry. If you're going to control an air device like a furnace or a fan coil or a mini split, you're going to put in an air-based thermostat. When in reality is that you would actually benefit more from an MRT or an operative thermostat. And in fact, one of the mini split manufacturers does make a control device that picks up radiant.
So we talked about the 10 factors, Robert. How does it work? Is it is there a hierarchy, or there's an interaction of all the factors, or is there a way to relate to that? How do you synthesize it all into one place? Yeah.
So what people ought to see or try to visualize or hear what I'm saying is take these 10 factors and treat them as ingredients of a cake. And you want to bake a cake, or if you want, you can look at it as a Rubik's Cube, surfaces on a Rubik's Cube, and you're going to try to solve the Rubik's Cube by getting the correct arrangement of the surfaces. So that's really what it is. And so when you get the right mean radiant temperature and the right air temperature and the right humidity and the right draft, and given consideration for clothing and metabolic rate, when you get all of that right, then you fall within what's called the predicted mean vote. And the predicted mean vote is associated with another term called the percentage, or the percentage of people dissatisfied is one way of call. Yeah, that's probably let's just leave it at that, percentage of people dissatisfied.
Okay, and that's
so what is this?
PPD is the term the industry uses, and PMV for predictive mean vote. So PPD is what we're going to focus on.
Correct. So what does that mean? Well, a guy by the name of Olaf Fanger did his PhD thesis on thermal comfort in the environment. And what he found is that when you were baking this cake, this indoor environment, putting all of the ingredients together correctly, that the least amount of people dissatisfied with the space fall within this design range. And this design range starts in the center at 0. And 0 would be like the perfect environment, where the person would be in total homeostasis, and which is almost impossible to get. Like, it's virtually impossible to have a 0 predicted mean vote where everybody is happy in the space. And in fact, at 0, you would still have 3 or 4 or 5% of the population unhappy. Then as you move from 0, it's the subjectivity, right? So then the design range at a 0 mean vote moves to plus 0.5 or minus 0.5. So the design range is at 0.5 on the negative side or 0.5 on the positive side, and everything in between that represents a predicted percent dissatisfied. So we say that if you get the Rubik's Cube right, you get the ingredients of the cake right, that at a range of 0.5 on the negative to the 0.5 on the positive, that roughly 10% of the population are going to be unhappy with the environment, and the other 90% are going to be happy with the environment. So that predicted mean vote is the design range, and we want it to be sort of in that 0.5 on the plus and minus side, and we want to try to achieve as much as we possibly can to have sort of between 85 and 90% of the population happy with the environment. So where we're at today, Christoph, is that most people, I would say, let's not say most, let's say roughly around 50 to 60% of people are actually unhappy with their environment, which places them on the predicted mean vote anywhere between, say, 1.5 to 1 down to 0.5. But 1.5 corresponds with a predicted percentage dissatisfied, or PPD, of around 50%. So if we're supposed to have a 0.5 and we're at a 1.5, that's just an indicator of how illiterate we are with buildings, right? That's just a testament to the illiteracy in the world of architecture and buildings.
Yes, or certainly that thermal comfort generally is not what the building has been designed to achieve. And that could come from not knowing about it, not investing knowing about it but ignoring it would be another way to do it, or knowing about it, intending to do it, and then during the delivery process, during the construction process and commissioning process, something went wrong. Yeah, that's a really good point. So PPD, PMV, you guys, it's a great topic. Dig in more. What you need to be doing is re-listening to that last part from Robert with a graph in front of you. It'll make it just super clear. We'll put a link to a graph with this podcast feed. So Robert, you also have one of my favorite areas on your website. Oh, I should have said this early on. Hello, everybody. Welcome to the Building Science Podcast. My guest is Robert Beanie. He has a fantastic website, healthyheating.com. Go there, but beware. It is you will fall in and maybe not come out for several days. It's a treasure trove of information. And one of the things you have on there is this indoor climate score, this concept of an indoor climate score. In the interest of time, I'm not going to have you go through the origins of where it came from, but if you could go through briefly what's included in the indoor climate score, and specifically dig into, you were bold enough to actually say the cost of indoor climate equipment relative to construction costs. So what's included, and in sort of your range of costs. And remember, we're recording, so you can take some time and pull this up on your website and talk from that. Which I'm actually going to do. Okay.
Okay. So a while back, we looked at our database of projects that we've done over the last 30 some odd years. And there's a trend, and that is that when people build to code and they only budget 3 to 5% of the construction cost in the HVAC system, it always corresponds to a PPD of 1.5, or results in a 50% dissatisfaction rate. When we looked at projects where they budgeted between 10 and 12 or 14% of the construction cost in the HVAC system, but also in better windows, better enclosure, that the PPD went down to like 10%, so more in the design range of 0.5 on the plus and minus side. So the PMV PPD, there's a correlation between obviously the amount of money that's invested in the indoor environmental quality. So that's not rocket science. It's just
you get what you pay for.
You get what you pay for. And we always say that it's not what you pay. Well, we say it's not necessarily what you paid for, it's what you didn't pay for that will get you.
Yeah. Mm-hmm.
Right? And so if you only pay 3 to 5%, you basically bought the downgrade. Right?
Yeah.
If we say that ASHRAE 55 is the standard, and you buy something less than the standard, you've bought the downgrade. Because people say in the world of construction, well, if you only allow 3 to 5% for your construction or your HVAC system in the construction cost, and you want us to build to the ASHRAE standard, well, that's an upgrade. Well, if that's an upgrade, then anything less than the standard is a downgrade.
I like it.
Right?
Yeah. So
we always say it's not, when you pay 3 to 5% for your HVAC system, you've bought the downgrade, and what's going to get you is what you didn't pay for, and that's things like cold floors, temperature stratification, too much humidity, not enough humidity, drafts, air velocity that's out of control, bad MRT. It's just all of the above, right? You've completely you haven't solved the Rubik's Cube. You haven't baked the cake. The ingredients were there when you started, but you didn't get it right. And the reason why you didn't get it right is because when you went to the store to buy the ingredients, you didn't pay enough money for the stuff that needed to be in the cake. And so you're missing the ingredients. Yeah.
Yeah, and this gets into something that let's tread lightly on the next few sentences here, Robert, because it's unavoidable to take this idea, how much should you spend on your heating, cooling, comfort delivery system, let's say it that way, and not to talk about the HVAC industry that is alive in North America today. And particularly, I have a lot of friends that they hear what I say, and then they talk to their HVAC installers, and they get different information, and they don't know exactly who to trust. And yeah, so it's not like I'm trying to say that HVAC contractors are not disciplined and hardworking, and it's not that they don't have good ethics. It's just like a different body of knowledge from what they've been exposed to typically.
Yeah. So if you look at the building codes and the relationship that the trades have with the building codes, they get judged on how they put things together. They don't get judged on the why.
Mm-hmm, mm-hmm.
Right? So their whole education process in the trades is the how to do stuff, how to fit pipes, how to make connections, how to do electricity and gas, and how to move air and how to move water and that type of stuff. But no one teaches them about human physiology and human psychology, the metrics, the 10 things that are inside the standard. That's not even on their curriculums. Mm-hmm. It's not even in the curriculums of most architectural and engineering programs. So so it's not that they're deliberately being illiterate. It's just that it's not part of their literacy program. And so what's happened is that consumers, and builders, when they look for service providers in the HVAC world, the literacy it's just a continuation. No one's asking those questions. And so what happens at our practice here in Calgary with our clients is that we spend a lot of time educating the trades guys, and we use our website to educate our clients. So when our clients come to us, they've had at least an exposure to this science, and they like what they see because it's, they get it. And then what we do is we sit down with the tradespeople, and we would now work with, like you guys work with a number of skilled tradespeople, and now they understand it. So when we say, this is why you need to do these things, not only do they know how, because I'm not I have how skills because I was in the trades, but they're the how people. But what's great is when you get the people that know the how, but now they also know the why. Wow, magic happens.
Yeah, they know why it's important. Yeah, and so I've had lots of project teams where they kind of talk about this limitation. They implicitly say it, and it's like they don't hear themselves say it. What they say is, oh, my installer takes care of the design. And, you can kind of perk your ears up and go, well, your installer takes care of the installation, and maybe they'll take care of the design. They'll have something that comes out of it. But with installers, go ahead, Robert, please.
Yeah, so, the metaphor that I use, or the analogy, I guess it is that, in the world of carpentry, you have cribbers, and for those that maybe not familiar with a cribber, that's typically the tradesperson that works with concrete forms. And then you have the framer, right, that's working with the wood part of the structure, so the walls, the above grade walls, and the roofing systems. And then you have cabinet makers. Well, a cabinet maker and a framer and a cribber, they're all within the carpentry definition. But you would never want a cribber, for example, doing cabinetry work. Now he may, let me clarify that. The cribber may have cabinetry making skills. That may be a true statement. But a cabinet maker, is a different person, like the different mindset. Their field of study is much different than the cribber or the framer. Now, I used to crib and I used to frame. I would never let myself do cabinetry making. I know what my limitations are. And it's the same thing with HVAC. Like, we have people who are HVAC installers, and they're very good at taking the pieces of the puzzle and putting them together. But the design of those pieces, that's a different skill set. That's in the world of the engineer or the engineering technologist or technician. And it's not that the trades guys can't learn that stuff, because some of them, like the good guys, do take the courses and they do learn the fundamentals in design. But we definitely want to make sure that we identify there's a difference between installation and engineering and design. Just like there's a difference between cabinet remaking and a difference between the framer, and there's a difference between the cribber. Yeah.
Yep. And so I've had the good fortune of getting to know a lot of these installers, like you said, and many of them like the fact that they recognize that they benefit from having a good engineering design to work off of. And by benefit, what I mean is they can actually embrace the fact that they're installers, and they can put more crews working more installs on more jobs, because they're not stuck on the job site trying to solve the Sudoku of where do I put the plenum. And we're implicitly, as an engineering company, we're implicitly working with the architect, hopefully early on, and we can say to the civil engineer, structural engineer, hey, can I have a plenum that moves through here? Hey, I need a truss bay that moves right down the middle of this room, and boom, it's there. And then the installer comes out and it says, check it out. Look, I've got room for my equipment. I got room for my plenum. We had a design charrette with an awesome architecture firm out of San Antonio, and the homeowners were there. And out of that design charrette came all the mechanical systems are going to be closet upflows or closet downflows, so that they can maintain their filters easily. And not just they, but their installers can do better maintenance. Mm-hmm. So yeah, we have another implicit problem quote with the industry, which is that architects and builders have long been trained in this history of the mechanical systems are going to be melted into my enclosure like butter into a baked potato. You know, it doesn't work that way. You need to leave room for the engine. Yeah. And they don't say no. Like what I get on job sites with installers sometimes after the fact when there's a comfort complaint, and I get to look them in the eye and say, why did you agree to even try this? You know, it was risky. Did you say this probably won't work? And they're like, well, I hoped it would work. You know, so one good thing about my company is we can tell the architect up front, no, that diffuser in that location, that's a risk. And we've even had on our plans
and that's,
say, don't do it. Go ahead.
Yeah, when you look at like the traditional, like even tradespeople that do design work, you know, unless they're a real special individual,
and
their focus is mainly mechanical. Like their filter that they look through is a mechanical filter. But I know, like for example, your business and my business, when we sit down with a client, hopefully before the architect gets involved, like we're talking about, you know, choices of land, we're talking about orientation, we're talking about geotechnical issues, we're talking about solar sun pass, we're talking about, you know, shading methods, you know, do we use external shading, do we internal shading, overhang, what shading works, what shading doesn't work. You know, we're looking at the building and the environment and the persons that are going to be in that environment, and we're thinking, and the, you know, the back of the solution, we're thinking energy and optimization. You know, it's just we have a different set of filters that we bring to the table, and only because that's our training. That's what we went to school for, was to look at that. And I know, like, and you know this too, is that when we hire engineers to work in our businesses, the engineers that started in the trades, they're the best. You know, because they know, they've been on the job site, they understand job site conditions, they understand the difficulties, they understand the flow of work, they understand the geometry, the pieces of the puzzle. And so when they come out of the trades and they get into the engineering world, they're just so much more valuable because they have that lens to look through.
Yeah, they know reality exists and they have to work with it. Yeah.
Yeah, and so the trades guys, you know, they're like a good tradesperson that's got design skills is very valuable, but it's very rare to find a mechanical tradesperson that can look at the macro picture and then identify all
and
of
the enclosure.
Yeah.
A sympathetic understanding of the enclosure functioning doesn't usually happen.
Yeah.
Yeah, so let's move on. We're getting toward the end here, you guys. So one more thing that happens when typical project teams are looking at mechanical equipment is first of all, they don't think about comfort generally. They just think, okay, what kind of equipment do I need to buy? And then when they do look at equipment, there's this this kind of knee-jerk or implicit infatuation with energy efficiency. And one of your favorite lines that I love is energy efficient equipment doesn't mean an efficient use of energy. And this brings up the term of exergy, E-X-E-R-G-Y. Could you touch on that? Maybe a few ideas about energy efficiency and exergy efficiency?
Yeah, absolutely. So this is, well, I really believe this, that when it's all said and done, you know, 200 years from now, our generation will be looked at on how we used the principles of exergy efficiency and not energy efficiency. Energy efficiency actually is kind of misleading. So let's talk about this. This is really important stuff for those that are online. And if you really have a passion for sustainability and earth stewardship, you really need to understand this concept. So I'm going to try to make this as simple as possible. So let's take a furnace. Okay, let's say it's a 98% efficient furnace. That furnace in a high efficient home only really needs to send into the space, you know, 95 degree air temperature, 100 degree air temperature, if that, under maximum load. All right. But when the gas comes into the furnace, it gets ignited. And the temperature of that flame is like 3,400 degrees Fahrenheit. So what I want you to do is, if you can, maybe in your left hand, hold up a thermometer that reads 100 degrees, and in your right hand, hold up a thermometer that reads 3,400 degrees. And you try to tell me that something that is running at 30 to 40 times hotter than what it needs to be is efficient.
Right. There is a gas furnace. Yep, exactly.
Right? And that applies to all combustion appliances that are used for conditioning spaces. So there's a difference between the energy efficiency of the appliance and the efficient use of energy. There's no efficient use of energy when we're using temperatures that are 40 degrees hotter, 40 times hotter than what we actually need 40 times hotter. And so this concept is really important from a sustainability point of view, because if we truly believe that hydrocarbons are a limited resource, they're a fixed value, every time we take a cubic foot of gas and we turn it into 3,400 degrees to generate 100 degrees, we never get that 3,400 degrees back. We can't put the genie back in the bottle once it's gone. And so what does that mean? It means that 100 years from now, when our next generations want to generate high temperatures for industrial applications like steel production and other types of things,
exactly, yeah,
the fuel source is gone because we've depleted it for a non-industrial application. And so today in the world, all over, we have the use of industrial grade temperatures for non-industrial grade use, like conditioning people in spaces. And that's why when we talk about solar and wind and hydropower, these are all sources of energy that don't generate 3,400 degrees Fahrenheit. They generate temperatures that are much closer to what we need for conditioning people in spaces. And that's why we need to marry those fuel sources or those energy sources with our buildings, because they're much more exergy efficient than combustion-based systems.
Well done, well said. And there's just for the audience to know, this goes on and on. If you take exergy efficiency principles and you apply it to a good enclosure, then there's new possibilities for delivering comfort through different types of equipment. Think radiant heating and cooling systems, high temperature cooling, low temperature heating. This just goes on, and it's this big, beautiful, I love the Rubik's Cube idea or the Sudoku. I do a lot of Sudoku. It just all fits together, and yet we have a public and a lot of professionals in the industry that are just piecemealing the information and doling it out in little teaspoons and a lot of marketing language. And yeah, well, Robert.
Yeah, Christoph, it's, the human body is beautiful and elegant, and we need to use it as our baseline for design. And so we ask ourselves, well, what are the temperatures inside our own skin? Well, our inside in our core is this, 98, 99 degree temperature. Well, we know in a high performance building, really good choices in glazing, really good structure, insulation, no or reduced thermal bridging, really tight, really conductive floors, large heat exchanger like radiant floor heating, radiant floor cooling. We can actually condition the people and the building with temperatures that is lower than the human body. Now think about that for those that are listening. So if we can condition spaces and people with temperatures that are lower than what we find on the human body, why the hell are we generating 3,400 degrees Fahrenheit? That's just absolutely insane. Right? So your description about all of this stuff coming together is so true. It's, again, the thermal comfort in the human body is at the center of design, and it brings in energy, and it brings in architecture, and it brings in physiology, and it brings in interior design, and it brings in all of these things. It's the great collaborator. It's the spoke or the hub.
Yeah, exactly.
Yeah, it is. And you're at the hub.
And it goes on and on, right? So the health impacts of how we deal with our spaces, and it just goes on. And, depending on my mood, I sometimes feel outraged and other times just disheartened. And, the reality is that I get to work with fantastic teams and help make this happen. And I love the way thinking about the airbags. Every car you buy now has airbags, but it wasn't that long ago where it was just I guess it was more like the high-end luxury automobiles that had airbags, and now it's everywhere. So I'm okay supporting these projects that they are visionary, they are industry leading, but that they are right now for not everyone, right? The developer-driven projects don't seem to yet embrace this. Wouldn't it be great for a developer to go, holy moly, if I start using this stuff that Robert and Christoph are talking about as my marketing platform? Senior living centers, if anyone listening, if you are involved in building a senior living center, pay attention here.
Yeah, absolutely. Well, this is, we could keep going on this topic, but one of the philosophies we have is that we see houses as a satellite extension to the institutional healthcare system. So what do I mean by that? Well, if I was to had 100 clients in front of me and we were talking about their home, we would ask the question, when you become infirm or injured or you need a palliative care environment, how many people want to move their life to an institutional healthcare facility? And maybe 1 out of the 100 wants to move. The other 99 want to be at home. Now, what does that mean? Well, in a modern healthcare facility, you have better ventilation, better filtration, better control over humidity, better thermal control, better lighting, better control over sound, reduction in vibration. You have all of these wonderful things in a modern healthcare facility. And people, when they get to that palliative care state, they would like to have that environment in their house.
Yep.
Right?
And it's
but the house was built to code.
No,
so
it's not possible.
Right? So it's not in today's model. We need to educate people that what you want in a good environment for when you're sick and injured and aging and dying is the same environment that you want inside your house. And that means when we build houses today, we have to think about them not in terms of the short term, but the long term. What's the environment that you want to be in when you're not feeling well? And it's not a code-built house. It's a modern healthcare facility, but we don't want the institution. We don't want what that institution means. We want the home environment. So there's no doctrine that says we can't covet the indoor environmental conditions of a modern healthcare facility for our own house. There's nothing that says we can't have that.
I love it. Yeah, I think about it. We talked about the standards being for healthy adults, and there's a lot of people that actually say things to me along the lines of, a lot of the stuff you talk about, it just doesn't really matter because it doesn't affect most people. They don't experience the discomfort, or their health can handle the little bit of mold that's in the air. But the reality is that these are stressors to the body, and things like mold mycotoxins increase your total toxic load. They trigger inflammatory responses and all sorts of autoimmune diseases that, yes, for a certain subset of the population, your body can cope with that. But those negative influences are still present, and if they don't need to be, let's remove them.
Christoph, the Titanic was a great ship until it hit an iceberg.
Yeah.
Right? And so that's what people think, we're on this ship and it's modern technology and it's never, it's just nothing's ever going to happen to us until you hit the iceberg. And that iceberg can be anything. And it's naive to think that, as healthy individuals, that something's never going to happen. Even if nothing physically happens to you from an injury or something like that, you will age. That we can pretty much guarantee that you're not going to avoid unless you die. Aging is something that you can't avoid. And so as the body ages, it has a different relationship with the indoor environment. And, we are not able to regulate our bodies the same way that when we're healthy. Now that's not for all aging people. I mean, some people age right to the very end and their systems are all very good. But there's a certain part of the population that when you do age, your ability to regulate temperatures is compromised. And, if you want to live in your home to the very end, then you want to think about these things.
Beautiful. So I think we've arrived at the very end. That's a good segue there. Let's bring this ship to harbor. And I just want to summarize by saying that this was actually a discussion of a wide-ranging discussion, but the central theme was on thermal comfort. And when we're talking about thermal comfort, we're talking about making humans happy, humans satisfied. What is it? The state of mind that expresses satisfaction with the indoor environment. Robert, do you have any final thoughts or thought?
No, well, yes, of course I always have some final thoughts. My thoughts never turn off. I would just encourage people that are listening that seek out individuals like Christoph and the Matt Reisingers of the world in your Austin marketplace. But Christoph, your broadcast is now going worldwide. I understand you have something like 6,000 listeners now. So wherever you are in the listening world, there are designers that are learning this stuff, that understand this stuff. And, building a house is a huge investment. It's a huge commitment. It's not the place where you want to just say, you know what, the status quo is going to take care of me, because the status quo is based on minimum requirements. It's not concerned about your long-term needs, and it's not concerned about your operating cash flow on a month-to-month basis, and it's not concerned about your assets. And so if you are concerned about your health, and you are concerned about cash flow, and you are concerned about your assets, you want to seek out those designers that are there to protect you through that whole process.
Well said. Robert, thank you so much. It's really been a joy and an honor talking to you today.
Likewise, Christoph. Thank you so much. Namaste, and have a great day.
Take care. Bye, Robert.
This episode is brought to you by Ultra Air whole house ventilating dehumidifiers. Here at Positive Energy, we've been working with these dehumidifiers for years on many of our integrated mechanical designs, and we've seen such great results for both the health and comfort of our clients. We even have an Ultra Air dehumidifier in our office, and we absolutely love it. When you're working with an airtight and well-insulated building, you quickly notice the outdoor air infiltration restrictions that occur, which allows pollutants and moisture levels to accumulate inside. So when you think about it, properly controlling that moisture in your home will definitely improve the effectiveness of your air sealing and insulation efforts, and will definitely improve the health and comfort for your client, your family, you. Just imagine being able to run your air conditioner at a higher temperature without feeling uncomfortable, and knowing that this improved comfort is coupled with fresh filtered air. These are just a few of the many benefits of incorporating the Ultra Air dehumidifiers into your home or your project. It really is an easy choice to make. To learn more about the best strategy for controlling moisture in your home, check out ultra-air.com, that's air with an E at the end, and see how a whole house ventilating dehumidifier can work for your home or project.